Here we have a SAT math question. Okay, let's go with the information. If mx positive c times nx positive 3 equals to 12x square positive 5x negative 3 for all values of x, where m, n, and c are constants, what is the value of m positive n? Okay, to get the value of this expression m positive n, what I have to do is first I have to get the values of the constants m and n, and then I have to add them to get the value of this expression. For that, we have to use the equation given over here. Okay, let me take the given equation as it is. That is mx positive c times nx positive 3 equals to 12x square positive 5x negative 3. Okay, now let's consider the stuff we have on the left side. We have a product of two binomials. When I multiply these two binomials over here, I'll be getting a quadratic expression on the left side. Already we have a quadratic expression on the right side. Whenever two expressions are equal, the coefficients of like terms can be equated. When I do so, I'll have a chance to get the values of the constants m and c. Okay, now let me multiply the two binomials over here using the FOIL method. Let me multiply the first terms mx times nx, then I'm getting m times n x square. Now let me multiply the outer terms mx and positive 3, then I'm getting 3 times m times x. Now let me multiply the inner terms, then I'm getting positive cnx. Now let me multiply the last term, c times 3 is 3c. On the right side, let me write this quadratic expression as it is. It is 12x square positive 5x negative 3. Okay, now m and x square. In the next two terms, we find x in common. Since both the terms over here contain x, we can factor x out. Then we get 3m positive cn times x. Now x is factored out from these two terms. Positive 3c equals to 12x square positive 5x negative 3. Okay, here we have a quadratic expression and here we have a quadratic expression. Whenever two quadratic expressions are equal, then the coefficients of like terms, the coefficients of x square must be equal, the coefficients of x must be equal, and the constant terms must be equal. So the coefficient of x square on the left side is mn, the coefficient of x square on the right side is 12, so they must be equal. Then we can equate mn and 12. And the coefficients of x must be equal, then 3m positive cn and positive 5 must be equal. Then I'm getting 3m positive cn, which is the coefficient of x on the left side, and the coefficient of x on the right side is 5. The constant term on the left side is 3c. It must be equal to the constant negative 3 on the right side, that is negative 3. Okay, now what I'm going to do is I'm going to solve for c in the third equation over here. For that, I have to divide both sides by 3. When I do so, this 3 will cancel. I'm getting c equals to negative 3 over 3 will become negative 1. Okay, now I'm going to plug in this value negative 1 for c in the second equation over here. Then I'm getting 3m positive. For c, we can plug in negative 1 times n equals to 5. Then I'm getting 3m. Positive times negative is negative n equals to 5. Okay, now let me solve for n in this equation. For that, I have to isolate n. So let me get rid of this 3m for that. For that, I'm subtracting 3m from both sides. When I do so, this positive 3m, negative 3m will cancel. I'm getting negative n is equal to negative 3m positive 5. To get rid of the negative sign over here, I multiply both sides of this equation by negative 1. That is negative 1 times negative n equals to negative 1 times negative 3m positive 5. Then I'm getting negative times negative will become positive. 1 times n is n. And this negative 1 can be distributed to negative 3m and positive 5. When I multiply negative 1 and negative 3m, I am getting a positive 3m. When I multiply this negative 1 and positive 5, I am getting negative 5. Okay, I have solved for m in terms of m. Now what I'm going to do is I'm going to plug in this 3m negative 5 for n into the first equation. Okay, let me continue over here. So we have m times n equals to 12. This is the first equation. In this equation, for this n, I'm going to plug in this 3m negative 5. In that case, I'm getting m times 3m negative 5 equals to 12. Okay, now let me distribute this m to this 3m and negative 5. When I do so, I'm getting 3m square negative 5m equals to 12. Okay, now we have a quadratic equation in m. So now let's get this quadratic equation standard form. That is ax square positive bx positive c equals to 0. That is we can get everything on the left side of the equation and we can keep 0 on the right side. So that we can solve this quadratic equation either by factoring or quadratic formula. So here we have number 12 on the right side. So to make the right side 0, let me subtract the 12 from both sides. When I do so, this 12 and negative 12 will cancel. I'm getting 3m square negative 5m negative 12 equals to 0. Okay, now I got the quadratic equation in m in standard form. Okay, we have to solve for m in this quadratic equation. So for that, I think we can try to solve this quadratic equation by factoring. If it doesn't work, we can go with the quadratic formula. Okay, to solve this quadratic equation by factoring, what I have to do is I have to multiply the constant of negative 12 by the coefficient of m square. When I multiply negative 12 by the coefficient of m square 3, I am getting negative 36. Now I have to get two factors over here, so that the product of these two factors equals to negative 36, and when I add these two factors, it must be equal to the coefficient of m, that is negative 5. So I think negative 9 and positive 4 will work. When I multiply negative 9 and positive 4, negative times positive will become negative. 9 times 4 is 36. So the product of these two factors equals to negative 36. And when I add negative 9 and positive 4, I'm getting a negative 5, which is a coefficient of m. Okay, further, I have to divide both these factors by the coefficient of m square, that is 3. Let me do it. So when I divide negative 9 by 3, I'm getting a negative 3 over here. So here 4 is not divisible by 3. We can keep this positive 4 over 3 as it is. Okay, now to get the values or two values of m of this quadratic equation, I have to change the signs of these two factors over here. Already it's negative 3. When I change the sign over here, it will become positive 3. That is one of the values of m. To get the second value of m, I have to change the positive sign of this factor. If I change this positive sign, it will become negative. That is the second value of m is negative 4/3. Okay, now I got two values for m. Now what I have to do is I have to get the corresponding values of n. For that, I have to plug in these two values, m equals to 3 and m equals to negative 4 over 3 into this equation to get the value of n. Okay, now let me continue over here. So we get n is equal to 3m negative 5. I'm going to plug in, first let me take m equals to 3 and then I'll take m equals to negative 4 over 3. When I plug in m equals to 3 over here, then I'm getting n equals to 3 times 3, negative 5. Then I'm getting n equals to 3 times 3 is 9, negative 5. Then I'm getting n equals to 9, negative 5 is 4. Okay, when m equals to 3, I'm getting n equals to 4. Now let me plug in the second value of m into this equation. Then I'm getting n equals to 3 times negative 4 over 3, negative 5. This 3 will cancel. I'm getting n equals to negative 4, negative 5. Then I'm getting n is equal to negative 9. Okay, here when m equals to negative 4 over 3, I'm getting n equals to negative 9. So definitely, I think the second pair of values for m and n will not work. Both the value of m and value of n are negative. When I add m and n, so definitely the value of this expression m positive n will be negative. But in none of the answer choices, we have a negative value. So this value m equals to negative 4 over 3 and n is equal to negative 9 will not work. So we can reject this pair of values. We can consider this value m equals to 3 and this value n equals to 4. So then we can get the value of m positive n. So then m positive n is equal to, for m we know that its value is 3 and for n it's 4. Then m positive n equals to 7. So the value of the expression m positive n is 7. We find 7 in answer choice A. The correct answer choice for this question is A7.